So I'm Stijn.
Hello.
Hello,
Hi, Stijn.
Tudor. I'm Stijn, and I work for Aardling as a senior consultant since August. I've worked with Matthias before. I think that started about 10 years ago when I started my career in software development. We worked together for a couple of years, and then I became a head of engineering of a startup in Belgium, which allowed me to further explore my skill set and my things I now use on the job right now. At Aardling, I consult for companies and also give trainings. Currently a lot of private trainings, but I'll also take some of the public trainings for my account.
Cool.
All right, I'm Matthias. I'm the founder of Aardling. We do basically domain modeling, software design, design strategy for all kinds of clients, as well as we organize the Domain Driven Design Europe conference. And yeah, that's the very short version. I've been doing this this kind of thing as a freelancer first, and then started this company, and brought in these beautiful people here.
Nice.
So my name is Maxime, and I'm also a software consultant and facilitator, pretty into DDD, and I'm also organizing the New Crafts conference in Paris. And I'm very happy to be here today, invited by Matthias to discover what Moldable Dev is. Really
cool.
Am I the last one?
Yes. No, not yet. Go ahead.
So I'm Thomas Koopman. I've been working with Matthias for a bit more than 2 years now. I've been doing development, domain-driven design development, consulting, training, and Zoom didn't like me, but now it does. So everything is okay here.
Cool.
And I am Ricardo. I'm just joined Aardling 3 weeks ago. Today is actually literally 3 weeks as a business development manager. And basically I'm here to support Aardling and Matthias as well, and the whole team to develop and to grow the business.
Oh, that's awesome. Right, nice to meet you all. So I'm Tudor Girba. I'm the CEO of Think. And I think this is our focus is to make the inside of software systems explainable in whatever that means. So in any dimension that's imaginable, or at least that's the ambition. And the motivation comes from the realization that today we, as a society, we look at software as black boxes. We rarely understand what happens inside, even when we talk with people that actually develop those systems. And we think that this is not a sustainable situation, especially given that everything is being built on top of software today. So we're reshaping the whole society on top of it. So probably it's a good idea to make sure that that foundation is sound and sustainable. So today here we want to talk about Moldable Development, and particularly I would like to explore this. The reason I'm very excited about this, and thank you very much for your time, because I think like Moldable Development has very interesting. It can complement very interestingly the kind of work that you've been promoting around, for example, domain-driven design, and about making the inside of software systems, a subject of conversation. And that's like an interesting thing that struck me when I was reading Domain-Driven Design, the book, right? This idea of a ubiquitous language, which was when you were practicing, but used to be called analysis and design. This was kind of like an implicit thing, but it was so great to see it written down as an explicit idea. But then even when we talk about something like a ubiquitous language, the question is, where does the language live? So if the language lives on a whiteboard, That's an interesting thing, but it's really about, the persons that are involved and the whiteboard. If you want to make it, if you want to make the system be part of the conversation, then we have to make that language live in the system. So it's the system that should carry it forward. The whiteboard is actually almost not really necessary. It's a different way of thinking about this idea of ubiquitous design, ubiquitous language. Okay, so what does multiple development mean? Multiple development is a way of programming through which we construct custom tools for every single development problem we encounter. And these custom tools are primarily targeted towards reading, not writing. It turns out that these same principles apply to the way you would want to write, but I would like to focus most of our attention on the reading side of development. Now, why reading? If I say developers spend 50% or more of their time reading code, would you agree with such a statement?
Yeah. More,
I think, yeah.
Right?
Yeah.
That's the interesting thing, right? Because I that's why first when I started to ask, I asked this question to several thousand people, and like we get this kind of, I get these same answers quite consistently. And at the beginning, I was kind of stunned. It's like only about maybe 50% of the people would agree that, because I was asking, do you agree that you spend 50% of your time reading code? And I said, no. And I was like, wow, okay, maybe the research is wrong. Because like there's this research that goes all the way, it's almost 4 decades now, more than 4 decades, that talks about this cost. And I said that, and then I asked them, so what do you mean by no? It says more. So that's like an interesting thing. And this is why I'm asking since then 50% or more of the time. And then all of a sudden, like almost everybody agrees that this is the case. Well, so at least the vast majority, at least of the people that I talk to, and then we see the same kinds of results in scientific surveys or in several studies that keep appearing periodically. But here's another question: when was the last time you heard developers talk about how they read code?
Well, I have a conference where people talk about that, so I'm not the
Yeah,
right
that's an
person to
interesting
ask.
thing. But actually, a lot of that conversation is about talking about the code that people read, not about how they do the reading. In the reading part is actually never challenged. And that's the thing. When you don't talk about something, that something is not explicit. If it's not explicit, it has never been optimized. And when we talk about 50% or more, we talk about the single largest cost we have, right? And this is a cost for which the budget is already allocated. We're not talking about some, extra thing. It's just, here's the money, you do whatever you want, and at the end we expect some results. And we as developers, as a group of people, we decide to spend the largest amount of that money on a single activity about which nobody talks, not really. And that's the thing. That's the thing that we want to explore. So what happens when you do talk about it? Because the one thing is, when you want to optimize a system, like the performance of a system, you will probably profile it, right? You will say, where does the cost go? And then you're gonna pick ideally the largest chunk of time that is being spent on an activity that maybe ideally has never been optimized, because that's where typically the order of magnitude lies, or at least the promise of it lies. And the same thing happens in software. We think that we can improve the ability of reasoning about the system with an order of magnitude or more. And the way we do it is we say, well, why do people read code? So that it would be great to have a conversation rather than just me talking, because then
Sorry.
it's...
Yeah, I was taking notes. Could you repeat the question?
Yeah, so why do people read code?
well, to know how to change it, I suppose.
To understand what's there, to know what it's doing.
Why would they want to understand?
What part is doing what exactly? What
But
part of
why
the
do
code?
why do they want to do that?
Well, usually to change it, right? There's usually a reason why you go read some code. It's actually making modifications or evolving the system.
So that's like an
You
interesting.
rarely read it just out of interest for, you know,
Right.
sometimes that's
learning,
studying, but
yeah.
that's learning, right? And it's deliberate.
Exactly, right. So sometimes you have these, maybe you're doing katas, maybe you're learning a new programming language, maybe you want to just study and learn how do they do whatever, right? But a majority of energy is actually spent on this interesting perspective. I want to find out how do I affect my system. And so if you look now back from that perspective, that's basically decision making. So from that perspective, reading is just one of the strategies to extract information out of data. And everything about your system is data. Like source code is data, logs are data, configuration is data, data in the database is data, the API, everything around your system is just data. And now happens that reading happens to be the most manual possible way in which you can extract information out of data. So, and it's also the least interesting thing that you're doing. The most interesting thing that you want to do is actually make the decision and affect the change. That's the interesting part, right? And that's basically where we start from. And that's what we want to focus on. How do we extract information out of the system? And then ideally, how do we make the system, give us that information without us doing a lot of manual work? And that's pretty much what the whole idea of multiple development is. Now, it so happens that this little thing has all sorts of ripple effects. Has all like second, third, and like with any kind of feedback loop, the interesting value is observed in the second, third, fourth the effect, right? So for example, if I look at something like DevOps, you would say, well, first order effect is that your deployments are going to be cheaper to build, right? So you're going to have cheaper deployments. Yeah, great, right? So you can decrease that cost of deployment. But if you're going to still do it, twice a year, but now it's not going to take you 2 days to do a deployment or whatever, or a week, it's going to take you 30 seconds. So you save that 1 week basically. So you have 2 weeks, you save 2 weeks of costs in a year, right? So that's one way of looking at it. The other way of looking at it is, well, say, well, if I can make a cheaper deployment, I can also deploy multiple times per day. And so that's like an interesting side effect. Now, if I can deploy multiple times per day, I can get feedback multiple times a day. But the more interesting feedback is not the technical one, but the business one. And so, right, so this idea is that every time we see a feedback loop, we should evaluate the feedback loop not based on what it directly solves or what it directly brings, but we should go and investigate the second, third, fourth order effects that we get out of it. Multiple development brings a new kind of feedback into development. So I would like to explore it from this perspective. Okay, now to show it to you, I will use a piece of technology that we are building, which is called Glamorous Toolkit. And that's a concrete environment. So in order for this whole thing to work, we need new kinds of tools. And I'll be showing you tools, but the tools, they are necessary, but the least interesting part of the conversation. The interesting part of the conversation is, what does it mean? It's like with deployment or with testing. You need a framework, you need to have a way to manage all of that. But the interesting thing, I remember, around late 90s, early 2000s, people were talking a lot about testing, but most of those conversations were about JUnit, right? And so because that's how we are, we have to start with some sort of concrete incarnation of an idea. Nobody talks about JRead anymore. It's still a relevant piece of technology, and you know it's used everywhere. It's just not what is interesting. And the same thing happens here. Also, we should look at Glamorous Toolkit as some incarnation, some idea. We still think it's highly advanced for today's perspective, but it's still just a technology. Okay, so I'm gonna share the screen. So this is Glamorous Toolkit. And we say Glamorous Toolkit is a moldable development environment. And by this, we mean that it's an environment that allows us to construct tools very quickly. So if I think about this, as I said, the problem that we're solving is, first of all, is that when we think about development, most of the conversations are about the active part. Like, how do I build something new? But then we notice that a large part of our energy is being spent on just trying to figure the system out, right? And the goal here, lots of this energy is being spent today on reading. But that's just a strategy, because the goal is to find a way to figure out which way to go in order to actually affect that change. So it's this part here that needs to be, that is presently highly unoptimized, because it's not really explicit. And that's what we want to address. Now, how do we do it? It's kind of like this. So if I have a hypothesis, you apply an analysis, you get some results, you interpret them. If you're confident, you make a decision. If you're not confident, you repeat. This probably sounds familiar because it's just a scientific method. So there's nothing new here from this perspective. Now, there's one little tiny problem. In software, software is highly contextual. So if you think about, like, if you go back to you know, to domain-driven design, there's this idea of bounded context, and there's like it's so hard to grasp at first, right? Because you say, well, here's an account, right? So that's an account, so it should be it has all the facets of the account are in that little thing. But then it turns out that just by looking at it from different angles, it turns out that it's much more interesting to model those different perspectives differently, have different bounded contexts for each of them, each of the perspectives. And the reason why this is so, that's one of the incarnation of this idea that software is highly contextual. We cannot predict the specific problems people will have in software. We can predict classes of problems that people will have, classes of questions that people will have, but we cannot predict specific questions people will have about their systems. So if we cannot predict specific questions, it means that when I have my hypothesis, there is no tool. There is no tool that gives me the information that I want to go and interpret. And that's the moment when I should go and ask, that's it. I said, well, do I actually have the appropriate tool? And if I don't have the appropriate tool, I should go and build it. That's moldable development. That's the flow. And we want to do this for every single development problem we have. And so notice here how this is not about how do we build the system, but this is literally how do I go from a question to some answer about which I'm confident enough, and that it will lead to some sort of an action. So that's what we mean by this moldable development. Now, notice of course here is that when this is your normal question, and then you say, okay, for this question I want to investigate it like this. Now, when I don't have it, I should go and build it. Now, of course, this is a meta step, right? I have to know, oh, now I have to stop what I'm doing, and I have to go and say, so how am I going to get the answer? There's like it's a difficult, it's not so cheap, and it's kind of similar to test-driven development, for example. Because in a test-driven development, they just say, well, okay, you know what you want, But no, now you need to go and specify what it is that you want. So you're going to build the test first, which is like a meta tool, and then I'm going to build the actual thing that I'm interested in. And that's not an easy. It's uncomfortable at first. I still remember the first time I didn't start programming TDD first, so I still remember how it felt so uncomfortable to flip my mind and put it, think differently. I mean, for me, it was hard even to write the test after I was finished. Flipping that, it completely like turned me. It was really, really, really strange. And this one can feel the same here, because literally before we make any decisions, we're going to challenge and say, well, do I have the right tool? And if I don't, I'm going to build the right tool. Now, of course, for this whole thing to work, this has to be very cheap. Because if this is not, if this is too expensive, it's just never going to work. So that's the reason why we need a development environment that makes this possible. So this is where the technology is absolutely necessary, just totally not sufficient. Okay, so that's the idea, and that's the perspective from which we should look at Glamorous Toolkit. Glamorous Toolkit is the environment that we created so that we can apply this type of thinking. Okay, now how do we? What do we apply it on? So here's one example that we have. So we spent a good amount of time working on this. It's actually more than a decade now. And the most of the time that we spent here was focused on finding a different experience to relate to a single object. And the reason is that our goal, as I said before, is to make the inside of software systems explainable. That's a broad goal. And of course, like when we talk about, a system that has maybe tens of millions of lines of code, then we kind of tend to think that, oh, that's kind of like a different problem than if I have just a single, a test case that doesn't work properly. Right, because that's just large problems, small problems. But it turns out that software has also this nice property of being fractal-like. So that means that properties that you have, like problems that you have at small scale, kind of tend to also appear slightly in different forms at large scale too. So in order to affect large patterns, that means you should go and affect the smallest possible pattern. And the smallest unit that we found in our systems was an object. And the question was, can we fundamentally affect how we look at an object differently? So if I think about an object, then we can think about the way we look at objects is through something called an inspector. Right. So here, for example, I have 6 inspectors. Right. And you might recognize these ones because, like, you have maybe some sort of a development environment, you put a breakpoint somewhere, and then you're going to get an inspector over the object. And every one of these inspectors is going to show every one of the objects as something like variables and values. Right? That's the kind of all objects are shown in this way. And so I said, well, and it's kind of nice because then it means that I build one tool and then I reuse it many, many times over. But at the same time, I'll say, well, if I look at these 6 objects, how are they different? So I can see, okay, look at that. This one is probably different from the other ones just because it has more state here, right? But other than that, it's hard for me to distinguish anything in this just by looking at this one. And the reason why this is so is because the view through which I'm looking at these objects is a generic view. It's just it's a generic view applicable to anything, and because it's generic, it's also not interesting because it doesn't show you what is specific. So if I now, instead of looking at this, I look at something like this, I take the same 6 objects and now I look at them in this way, I have a totally different impression here. So this one looks like some sort of a fraction. This looks like a folder over here. This looks like a picture. This looks some sort of a curve. This looks like some sort of an algorithm, and maybe even some sort of a data structure over here. So I haven't done anything with the object. I didn't change the thing that I'm looking at. The only thing that I affected is how I'm looking at it. And that's a tool level problem. This is not a system problem. And that's an interesting thing because, for example, if you look back at this idea of quality in software, we, for the longest time, and even today, we have this idea that, oh, we have to have clean code. And that this is a measurable, this is something that is measurable. Like you can look at the code in isolation as an artifact, you can measure it, and based on that measurement, you can say whether this is good or bad. And the implication here is that bad code is going to be less understandable than good code. But then here I can see that if I don't change the thing that I'm looking at, I only change how I'm looking at it, how I'm looking at it, then all of a sudden I can maybe get to an order of magnitude difference in terms of speed and accuracy of the kind of lessons that I get just by investigating. So and this difference doesn't come from changing the system. The system is exactly the same. We've only changed the way we looked at it. And this is basically an indication that the way you look at the system is as important as the system itself. And that understandability is not just a function of code. It's a function of code, it's a function of the tool, but it's also, it also depends on the skill of reading, because this is no longer taken for granted.
So is the consequence that we would be more okay with well, bad code, whatever that means, if we have better visualizations, and that we therefore, because there is a lot of bad code, could actually understand a lot of code better without having to refactor it?
Well, in a way, yes, but in the other way, there is no bad code. There's only code that is less explainable for someone and more explainable for someone. Because if I take the same bad code and I take the person that wrote that code yesterday, and I take someone that doesn't understand what that code is, they will have we can see a significant difference in the ability to affect that change between the two people. Of course, we should still go and create, and once you learn that certain types of changes, certain types of pattern enable certain types of changes, you want to go and apply those, because of course there's still value in understanding how you're going to build the system, but we should depart from the idea of saying that this is bad code.
Well, I agree on from the point of view of understandability, but there's also bad code for other factors like performance or coupling or other reasons, right? But I get your point. It makes sense in the from the point of view of readability.
And that's like an interesting thing, because to take performance. Very often, performant code is made to be less easy to digest. So that's like an interesting thing there. Not always. Sometimes you can find elegant solutions that are also highly performant, but it also happens that an interesting path towards adding some performance is just going one level deeper and writing it in depth rather than at your high level of computation, and then all of a sudden makes the whole thing more complicated to understand, because maybe you're going to mix and match different expectations, and it will work for this case, maybe going to be breakdown in the future, but it solves the performance problem. So again, there's this tension between bad code and the properties that we want to get out of it. But But yes, it is easy. Like, I do think that we can enhance our ability to reason about systems many times, as opposed to when people read code. There's no doubt about that one. But then there are all sorts of interesting effects that happen as a result of using it. So again, if we can measure it as just as a first thing, say, well, okay, you're reading code, I'm not reading code, I'm going to build a tool that does the reading for me or compresses the system in the way I want to look at it. But at the same time, so we can measure that difference, and I think there's going to be a large difference there. Well, I've seen it in practice many times. But the very interesting thing is what happens when you're actually going to use these kinds of views and construct them actively as part of your development, because this will exercise your design in a way that functional decomposition doesn't. So we see it many times that we write maybe a test first algorithm, but because we can't visualize it, we're going to change the inner structure, but the assertions remain the same. So we have a force, because it was always nagging me. There's like this, when you have this TDD workflow, you have, write the test, make it really blah, 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 and then at the end of it, you say refactor. And I was like, how do you know? How do you know what to refactor? How do you know when to stop refactoring? And it was always a thing that was kind of left somewhere. And the way we're doing it now is we're saying, well, how do you feel about the presentation? Do you like the story, the narrative that you can tell about the thing that you built? And if you don't, then go and modify it and stop and modify that system until you can visualize it the way you think it can be visualized. And it has an interesting effect because it took us a few years to figure this one out, that this was happening. It basically changes the design in a way that you would not see if you would only write tests, because there's like an orthogonal force that you get to exercise through this other feedback loop. Okay, so that's the core idea. So what you're seeing here, these are actually inspectors. So literally, this is what you would see. This is how our inspectors look like. And so these are like 6 of them, 6 objects, right? These are the normal state that any object would be visualized through. And then you can have other perspectives. So this is thing number 1 here, is that there's no single dominant decomposition of anything in software. So any part of the software can be seen in many different ways. And we want the environment to be able to host these perspectives as a first-class citizen, basically. And some of them can be textual. Some of them maybe are less so. And it depends on whoever wants to, whoever is interacting with those objects. Now, of course, now the question is, what do we put in an object? What is an object? So what you're looking at here is, this is a Smalltalk system. And so we chose to work on a Smalltalk system because it's very, very nice for enabling experimentation, but the lessons apply to all sorts of other technologies, so they are not limited to this. But maybe to exemplify how this one works, let's actually go and take an example. So here I have an example of just working with a REST API. So if we go to GitHub and go to these URLs over here, if I go to API GitHub.com orgs, fincom, this is our organization, you're going to get a JSON back that looks something like this. And somewhere in this JSON, we get things like something underscore URL, which then gives us a URL that we can then use. For example, here I have the repositories of the organization. And then, of course, this is going to be an array of JSONs, each JSON pointing to a specific repository. So from there, you can actually go and get another URL. And if you put that one here, then you're going to get the details about the repository. So let's actually try to go and investigate this one. So we have, this is a problem about some external API. And we say, well, how do we enhance, how do we read, how do we learn about what that API allows us to do? So I'm going to start by saying here I have this URL that I started from. So this, the one about our organization. And I'm going to say, well, this is an HTTP library, and say I want a client, an HTTP client, get this URL over here. So if I execute this, I'm going to get the resulting object. And then, of course, the resulting object is a string, and these are the contents of the string. Any of you, by any chance, is familiar with Smalltalk syntax?
I've only played with Smalltalk once at an open space conference.
Great.
Yeah.
So if you're not, and you don't have to for this purpose here, read this. Try to read the text as a sentence, basically. And so the interesting thing here is that usually the sentences here end with dots. So dots do not delimit. It's a strange thing because the dots do not delimit words; they delimit sentences. I know it's weird, and you know, like read it like a normal English thing. So I see here a client, you get this, and then I get a variable called JSON, and I'll have this one now. So I see here, okay, this is a string. Okay, string is nice. I can see the result. But what is not so nice is that this is a string. I don't like to work with strings. So first thing you see when first thing I do when I see a string, I want to go and extract the structure out of it. Now I know that this is a JSON, which means that I can use a JSON parser here. So I say, well, this parser from string, parse this JSON and see what do I get here. Well, what I get is a dictionary, right? And now the dictionary shows me, okay, there's a key and value. So I can see things like our repos URL over here, right? Okay, so now I also don't like to work with dictionaries because they're just too generic. So, but if I'm looking at the data that I have in front of me, it kind of begs for a first-class entity, right? It kind of begs so that this is an organization. So I would like just take this dictionary and I'm going to put it in an organization. I will put it in an organization object. So I'll create, I have here a new class, which is called organization, GitHub organization. I will instantiate that one and I'll say, put this dictionary in there and see what happens. And of course, this class has already some implementation. If I look at it here, so here I'm in my, you can think of it, we call it the playground, but you can think of it as a notebook. And there I'm already browsing the logic that I have. I can see that it already does things, but let's actually see what happens now if I inspect the result of this. So what happens here is that I get another inspector, an inspector over a GH organization object. But now this object says, well, look at that. There are some repositories over here. There's a repositories view. I can take a look at it like this, or I can take a look at it like this, right? So from an organization, I can have a view which says, here are the repositories. And so this is one repository over here. And if I see this repository, I can go into it. And I can say, okay, this is now a repo object. And this repo object now has other views here. I can take a look at this. It's not so interesting. This is much more interesting. These are the events that are listed from this repository over here. But I can also take a look at the contributors view. In this one, apparently, there's lazily getting things. So now I don't have a table, I have some sort of a chart here. I can click on one of them. And then I can say, okay, this is now a contributor object. And the contributor object, for example, knows its avatar, it knows its own events, and so on. So I can go and basically explore my the system, the things that the objects that I get from the external source, but just reifying enough of them so that I can have first-class entities to which I can attach these kinds of entities, these kinds of views. And then using these just little things and then concatenating these views, and now kind of have a browser that documents this API that I'm seeing somewhere else. So are there questions so far?
What about the GH objects that you have, the GH repo, contributor and stuff? Did you design them yourself before doing those stuff? Okay.
Exactly, right? So they exist, obviously. So one interesting question and exercise here would be, well, why don't we create one? How do we go from just a, just a JSON, just a dictionary, and let's create one. So I'll just do one here. I'll say I want the my organization new, and I'll just do exactly that. I have what I have here on top. Raw data, and let's say I want to put a dictionary in there. And okay, so now it tells me my organization doesn't exist. There's no class called like this. So I say, okay, let's create it. So now I have my organization. Yeah, I'm gonna put it in the superclass. I'll put it in a workshop package. And now I can say, okay, create it. So great, now it's created. And then I say, okay, raw data doesn't exist as a method. So this is gonna be a message sent to this object over here. So there is no method called raw data in this object. And so I probably should create this method. And again, here it says, let's create this. I get an editor. This means this is a method. This is a selector of a method. So raw data is the message. And this is an argument. So in this case, there's a method with a single argument. So in this case, it's a setter. And we want to say, oh, let's actually create a slot called raw data in my organization and just store this dictionary. This is, by the way, a typical pattern that we see when we want to browse some unknown data, some whether this is data or this like APIs or some XMLs representing whatever. We kind of just say, oh, I don't know what this is, but this kind of represents that. So let's just store it there, and then we'll see what I can extract from it. So I want to reify my organization. I want to reify that one by just cherry picking what is inside this big dictionary, because maybe I don't care about everything at this point in time. So now, if I execute this, I get in my organization, and I have the raw data over here, and there's nothing else. So it's just I have the raw view here, and I have the print string. So like every object, so any programming language would have a default way to print an object, right? So this is the kind of thing that you see in your, in the log, for example. Now, because there is no single perspective, no single thing to look at, no single perspective to look at any object, we think, well, there shouldn't be just one printing method. There can be many printing methods. This is thing number one. And thing number two is, well, because now we can show other things than just text on the screen, and maybe we should make those printing methods print widgets rather than just text. And this is how we get to these kinds of views. So how do you tell an object to print itself typically? How do you specify how you want an object to print itself in your
like
favorite
a
toString
method?
toString, right? And that's going to be a method in the class of the object that you want to print, right? So the same thing happens here. All of these views here, they are methods in the class of the objects that we want to view, right? So the one that we see here on the end, this is a meta view. So the meta view gives me the editor of the class of which instance this object is. So here now I could do something like, the other thing that I have is, if I look at the state of, for example, here, every single pane here, so this is a pane, this is another pane, every single pane, it also has some sort of a self. So I can do here, for example, something like self. So this is the same kind of notebook as here, but here I have a self, and self would point to this object. So I can work with it. It's like a REPL if you want, but open just on this specific object. The other thing I could do, I could just directly access from this notebook playground. I can access the local or the instance or the slots of these objects. So I can say raw data, and I remember last time. So actually, I don't have to remember. I double click on this and I say, well, okay, I can see here that there is a repos underscore URL key in this dictionary. So I know that this is a dictionary. So I can say at repos underscore URL. So if I execute this, now I'm going to get a string back, and the string is going to be this, this URL, right? So that's kind of interesting, because now I can say this is a URL, and afterwards I'm going to say, what do I do when I have a URL? When I got here a URL, I did this kind of JSON blah 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 thing, right? So I'm going to do exactly the same thing over here. I'm going to say, okay, given this URL, give me the JSON. I say, okay, here's the JSON. Is this array of repositories, right? So that's a JSON, and sorry, that's a string. So what do I do whenever I see a string? Well, what I do is I obviously parse it, and I want to extract what's in the string. I want to look at it's too low level for me. So I'm going to do exactly what I've done here. I'm going to say, okay, I want to get all of these ones, and then at the end I want to parse it. Actually, this is no longer a dictionary. It's going to be an array, but that's it. Now I have my dictionaries of repositories. So I could get out of this. I explored right in the context of my little object. And now that I kind of like this idea, I say, well, actually, I would like to see this here. Right. So first, I could go to my meta view in my organization. And I could say, well, let's actually go and create, let's create here a method that does kind of the thing that I've done here, which is, how do we call this one? Repos. I don't like the name, but let's keep it like this. And I simply pasted what I got from here. I paste it in this editor of the method. So I'm going to say temporary. If I save this, and I'll get the method here. So I have this is a unary method. In my organization, I can say, give me repos array. Okay, so that means that now if I delete this one, and I say self repos array, and I execute that, I'm going to get exactly the same thing. Make sense? So what happened here is that I kind of started to program in the inspector. I didn't program in the code browser, right? I programmed against the data. So there's no, which is very useful, especially when you're doing reverse engineering, when you're trying to read something that already exists and reify your understanding as you go. Now, the next thing that I want to do here is I still would like to, I don't like the fact that I have to go back and forth, that I see this, array opening up in another pane. I would like to see it here as a documentation of my organization. So I would like to create a new view. So I'm going to do exactly this. And I saw a view is like a toString, except it has slightly a different format. So let's say something like a raw, we can call it raw data 4, and we take a view here. So this is now a method. We're defining a method that takes an argument. This argument is like a string, only it's not a textual stream, it's a widget stream. I also said that I can have multiple views for every single object, which means now that I can't hard code the name of the method because there can be many. So I have to distinguish these methods somehow else, and the other way which we can distinguish them is through an annotation. So this is like a, I can add something in that. So now I can say I want a view here. So what do I want to see? I want to see a list, and the title of this list is going to be repos, for example. And the item. So this is actually like a tiny internal DSL. Say, create me this widget over here, a list, a title, and so a list. I need the title that should appear here, and I need to see how do I get the items that I can that will appear here. So now we're going to say here, well, self repos array, and if I save this, I get a new method, but so I get a new view. Right, so now I have exactly the same thing that happened here, but now it's available here. Right, so if you do this, if you go through this process, this is a very slow motion here, but basically when you get to do it, you're naturally going to build a trail of two things. First of all, is you're going to build a trail of concepts, because now, of course, here, what do I see? I see a collection of dictionaries. I don't like dictionaries because they don't give me any meaning. So I want to transform them into some first-class entity. So what should this first-class entity be? Well, it's going to be a repository because it begs for that name. And so I'm going to create, and I'm going to do exactly the same step that I've done the first one, but not over and over and over. It's just going to reply the same thing and over and over. That's pretty much it. That's the flow. And you can go to all sorts of input data and apply this the same flow to how we kind of read through our systems. I'm going to give you other examples, but this is how this one looks like. So maybe I suppose that there are questions.
Yeah, well, the demonstration works well because you have an API, and so you get data live and you can play with it. And but what I'm wondering right now is how we could use that way of looking at objects during a debug phase, or calling any kind of methods and getting results, and see what this system is actually doing. And because the way we do it, like in TDD style, maybe we can call a method and then write a test saying, okay, if I want to refactor, I can add a test and say, well, this method should return this exact data, and then I can refactor because I have the check behind. But it's not, well, as deep as what you've shown here. So yeah, I would like to know if it's possible to do that.
Yeah, very cool, super cool. Yes, absolutely, definitely. But first of all, this is not necessarily deep. It's kind of orthogonal. So you want sometimes you're going to decompose a problem functionally, and when you can do it, then a test is really a nice tool to use, because it's just exactly what you want. You want to say, this is the input, this is the output. That's it. Yep. So a test is a beautiful analysis for that. But there are all sorts of questions. Like, for example, here we did not explore an algorithm. We explored structure, and all of a sudden a test is not useful because you have no clue about what the assertion is, right? Because you need to discover here. But the other thing to see here is that you can play with the meta levels in interesting ways. So let me see if I can find an example. that
And
would,
yeah, and also where is it saved, and how we can, do we have a library of stuff we created, and then we can
sure.
reuse everything?
Sure. So everything that you see here comes from GitHub.
Okay.
So all sources here, they go directly, they can go to GitHub. So in fact, if I look at the repositories that form, these are all GitHub repositories. And so I could create now here a new repository and maybe create a repository on GitHub, clone it here, and then start adding things to it and then pushing it from here in using this programming language. So yeah, this is how we are sharing things. So what you're looking at is this idea of an image that comes from Smalltalk. An image is not a unit of code storage, because it's not where you store your code. It's a convenient thing to to play with. Maybe but it's by typically you want to use it as a temporary artifact. So as soon as we have something that we like, we push it to GitHub or to some external storage, and then you build it again.
You're building an extended REPL actually for every context you should have. Okay.
Yeah, exactly. Okay.
So let's. Can I? Sorry. Can I ask a question? Yeah, I was wondering. So you said, well, tests are for some kind of problems. This is a more structural example. Could you give some other kinds of problems that this solves?
Yeah.
Where tests are not great.
Oh yeah, sure. But let's go and mix and match a bit both of these questions. So this is an example of. So before we saw it, we did some sort of reverse engineering of data. And interesting enough, at the end of our effort, we had a live documentation, because like the tool gave us a browser through which we could conceptually navigate through our data, right? So this is an interesting thing. But sometimes you want to build something from scratch, like like you're going to do your sessions and draw something on the whiteboard. When you don't have a system, a whiteboard is an interesting medium to use. As soon as you have a system, we never want to draw manually that system on the whiteboard, because as soon as we're drawing manually on the whiteboard, we are documenting what our belief about the system is, not necessarily how the system actually is. So it matters a great deal when we evaluate that whiteboard. So whiteboards are useful for the future, not for what exists, not for the present. So as soon as we have a system, we want the system to draw itself. So this is an actual, here's an example of a domain. And this is a domain that is restaurant automation. And so here I have, let's take a look at this. So this is a system. So imagine a restaurant automation system called Cozy Corner, with a room, 2 tables, and a kitchen. Right, and in this restaurant, we have a waiter at the tables and a cook at the kitchen. And then one of the interesting problems in a restaurant is how can these actors communicate with one another without them knowing of each other? And the reason why it's nice that they don't know is that these are actually really bounded contexts. They have completely different rhythms, different forces that dictate how these ones behave, how these ones behave. So for example, shifts are not the same, for example. So we want them to communicate without them knowing of each other. This is an actual problem. And when we worked with, from a business perspective, we looked at it like this and said, well, how could we do this mechanism of communication? And we thought, okay, let's think that these are actors, and they communicate through messages, and the messages should kind of propagate like this. So John Waiter goes to table 1, talks with the customer, digitalizes and the customer says, I want a steak. And now the John Waiter says, okay, digitalizes this order, and sends the order at table 1. Table 1 doesn't know what to do with it, forwards it, and this message basically forwards itself until upwards, so bubbles, until they find something that knows how to handle it. In this case, Cozy Corner knows how to handle it. And then one of the things it does is going to say, okay, let's produce this steak. And then this message finds its way to the cook. So now the cook has an item on the to-do list. And then it says, okay, once I'm done, somebody should come and deliver it. And that's another message that should find its way to the waiter, right? So there's an algorithm here. We don't have to go into all the details of of why this is like this. Interesting enough is only that this is an algorithm that we drew as a brainstorming session on a whiteboard, right? So this picture was drawn before we had a system. And then, of course, when we say, oh, let's implement this, you can do something like this, right? So here I have a little API, a little Fluent API, or maybe not, like a kind of a internal DSL, right? So I have a venue here called Cozy Corner. I have an area in the parent Cozy Corner. I have a room in Cozy Corner. I have a table 1 in the room, table 2 in the room. I have John Waiter in table 1 and table 2, and Jeff Cook in the kitchen, right? So I guess you can, if you can read this one, and that's what we typically call by clean code. You can say, okay, make this one be like the domain that you want to describe, and that's totally fine. And if I squint at this code, I can kind of imagine this picture, right? It's imaginable basically, but I don't have to squint at it. So if I execute now the same code and I inspect the result, I'm now inspecting a venue, and the venue knows to say, okay, here's a Cozy Corner with the kitchen and a room and a tables and a waiter and a cook, right? And the other thing was, okay, so this is like the structure of it, because that's the only thing we created here. But we saw here I had this red thing that was transformed into the blue thing. So that's some sort of a logic there. And so actually, let's go and endow them with when something X something. So that's the kind of logic that we thought of creating. Again, just in some internal mechanism. You can think of it also as a workflow system if you want, but we thought of it as if it's actors and messages. So if I inspect this one now, I get here a Cozy Corner. It has these kinds of abilities when something acts something. And they show here, and of course I can go here and then take a look at them if I want. I can even go and modify them here. So I'm in an inspector now, and in the inspector, I'm looking at this at the DSL. But think of it like the DSL is not the editor. The view is a tool for reading, not necessarily for writing. So this is also a difference with moldable development versus something like domain-specific languages or model-driven engineering, or is that to create those, you have to have the complete semantics figured out before you start generating your code. While here we can explore, because we don't know exactly what it is that we want. So we want to get our hands dirty, but just have our object say, oh, here's a perspective that kind of looks like a domain-specific language, but it's just a reading tool. It's very, very cheap to create. And you can just add views like that to anything. So far, we have looked at a venue object. So, but the interesting things are these arrows, right? Because that's where the algorithm is. And that's what we want to go and play with. And so let's see what happens when John Waiter sends a place order message to table 1. And then again, here, this place order is an instance of place order, the message here. So I can look at it and says this is a message. And this one has an actual order. So you can see how they're the same concept basically has multiple layers in there, right? And the order has an order item. So it's made out of a collection of items. And then order item is made out of a menu item, which then points to a consumable, which is the steak, and has a price. Interesting enough, for example, the applicable tax, the VAT, is at the level of the menu item, because, for example, there are different countries where if you take away the, if you take the menu item to go, you have a different VAT than if you eat it in the restaurant. So, so this is why we have two different concepts here. But again, the interesting thing is that what's going to happen here when John Waiter is going to send this one to table 1. So I'm going to now inspect the result of this. So what do I see here? I'm no longer, first of all, I'm no longer looking at a venue object. I am looking at a message object. And it's the message object they wanted to say, well, could you please describe yourself? Like, where did you go? So, and I can see, look, it started from John Waiter, and now Jeff Cook has an item on the to-do. Because that's what I expected to see before. And so now if I look at the to-do, this is the to-do list over here, and I say, okay, I'm done. So what happens now? Okay, it goes back to John Waiter. So, which is exactly what I have seen in the drawing that I saw, that we built manually before we had the system. And now we say, well, this is the algorithm, we want to see it here. And this is one of those kinds of cases where we started by just seeing this. We were not able to see the lines because the messages didn't know where they went through. It was all just side effects. So like this one telling this one to do something, it was just, you know, something that just went through the whole cycle here, but it didn't remember where it went through. The other thing that it didn't know that, for example, here we see I'm still inspecting the original one, the red one, but from the red one I have a blue arrow, and then afterwards I have a the cyan one here. So for example, if I look at the consequences, so this is my original place order, but then I have a produce order and then a deliver order. Right, so again, a different representation of the same object, but now I'm reasoning about, you know, is the right consequences? Do I have the right consequences here or not? So now, why is this interesting? Well, this was interesting because then we could do other kinds of things. For example, let's consider some another whole new kind of use case. Like imagine a guest coming into the restaurant and hooking into the restaurant, opening the phone, hooking into the restaurant and saying, okay, I'm here and I want to, there's a new guest, nothing happened with the restaurant, same restaurant. So the only thing we've done is added this into the graph. So now what happens if Alice guest, for example, places an order? Notice how the whole thing works, goes all the way to the cook. The cook has an item on the to-do. So what happens when we do this? Let's actually browse this. Oh, look at that. It goes to the waiter. So maybe in this case, it's a good thing because no, it's not a self-service restaurant, but it's a, you know, you can order it, but you're still going to be served type of restaurant. So maybe that's good. Maybe it's not good because maybe you did want to make it a self-service. So it depends on you. But the point here is that we could just explore here a whole new business case. It's like a whole new category. And we could explore it. We said, well, we think that our language, or like the way we decompose the system, is expressive enough. We said, okay, so what does it mean that it's expressive enough? Well, let's take another, something that maybe we haven't thought about and see how do we express that one. So this is a new use case. And then we could express it here, and this is how we showed what that is actually expressive enough. So notice how here we have a conversation about an algorithm without actually looking at the algorithm. We just look at some objects and some views of those objects. And those views actually compress things in interesting ways that are good enough to actually reason. So first of all, did you understand what I just showed you here?
That's pretty cool.
Yeah, it's very impressive.
But the
I
thing
like that
is,
one.
Yeah.
Very much. Yeah. More than the one you showed previously. Yeah.
Mhm.
I see a lot of cases where I could use that with domain experts and directly code stuff with them, where a mob or an ensemble programming makes really sense. Yeah, sometimes it's quite difficult to do that in real life with a programming language like, I don't know, Java or C#, whatever. So it's hard for them to get a sense of what is going on in the code. But here you have the view that helps to visualize if everything is correct and if it's still aligned with their vision, and it's pretty cool. So now, yeah, of course, I want to know what's the next step when we have done those things. We need to translate that into, like I said, Java or C#, whatever. Do you have any experience with that?
Yeah, of course. Yes. I think we're going to go to that one probably in the next session.
Yeah. Okay. Cool.
But it definitely is a super important area. But so maybe other ones, someone else has maybe questions or things to say, because otherwise I have a few things to say before we finish.
But am I correct that the idea is that everything you're showing that you're so you start from solving a very local problem. I want to understand how this works. I built something custom for it. And then gradually, as you find more uses for that thing, maybe it becomes more of a generic thing at some level, where you can say any, like, for example, you want to visualize a message going from the waiter to the cook. And then later you start to reuse that as a visualization for a message going from anything to anything, and then start sharing that specific visualization so you can use it across projects. Is that sort of the idea, or?
No. Yeah,
No.
I mean, yes, it can be, but you can think of these ones more like patterns than code reuse.
Yeah.
You're not reusing libraries, you're reusing, and the thing is, this is what happens when the cost of the tool becomes ridiculously cheap. I mean, the difference between this one and this one is literally a few dozen lines of code. So once you're fluent in these ones, and then you don't have to create everything they call super fancy with all the shadows and whatever. Those are not necessary at first. It's enough to do something that is dirty enough, just like we saw before. Like a table was way more than just that raw, that's just a raw view. And this is how we gradually go up. But the view here, the specific view, is not going to be reusable, and explicitly not going to be reusable across contexts. Just like how you don't want to go, from one bounded context to another, they will have different meanings. You don't want to reuse beyond that one. There's a very strong correlation between those two principles. Maybe we can explore it a little bit more next time. But that's one interesting thing. But what we do learn is classes of problems. So when, for example, drawing graphs, this is, you do not want to invent drawing graphs for every graph you're going to draw, right? So a class of problem, you can go and extract and build something that is more expressive for it. So this is kind of the mental frame. Does it make sense?
Yeah.
Right. So which means that we're going to end up with thousands of views. So any system we build literally will have thousands of customizations. So at different things that we look at, they're just going to look completely different. So here, for example, I have a place order. If I click on the cozy corner, I can see the cozy corner. And so I'm just now navigating through it, right? And then here I can say, what kind of messages did you handle? Another completely different kind of thing, another kind of question that we say. And this is, like this can come, doesn't have to come from here, it can come from the database. This is the other interesting thing, because if I'm now going to look at this thing, right? This thing comes maybe from the database, but when I reify it, how did I reify it? Exactly like how I did this uninteresting thing from the JSON to construct the first level object that knows how to present itself. It doesn't matter where the data comes from. And so the tools that I use to actually explore the domain for domain discovery are also very interesting debugging tools, second level support type of tools that are at the level of the domain, right? So that's what you're seeing here. Like this is a log, and here on the left-hand side, and then on the right-hand side is the view that I used at the level of abstraction that I thought of, right? And so that's this is how these things combine a bit. are there other maybe questions? No? Because I want to go and step further. So here I showed you like a succession of actions for one single problem. But then once I have something like this, once I have a logic like that, I don't have those views. They don't have to stay only in inspectors that I have to execute some code to see. I can also assemble them like this. So here's the same kind of thing, but now it's in a document here. And now this document is live. So I'm creating a narrative about the inside of my system, and now I'm writing a document about it. Right? Now this document, in this case, is a visualization about the algorithms that I could see before. And this is live too, so I can actually click here and then play with this. If I want to, and the interesting thing is that this is actually not, this is also generated live. Now the question is, where do we get the information from? Because before I needed to have this little snippet that produced an object so that I can look at the views, right? This is how I played with before. But now I have the views, where do I get the objects from? And so this is led us to something that is called, that we call examples. So examples are like tests, but they have a little property, and their little property is that, so let's take a look at, okay, let's take a look at this one. If I browse this one, I can see that, what happened here? I don't know. So I can see this is an example, and in the example, I can. This example is like an executable. It's a unary method. It's like a test. In this case, it doesn't have an assertion, because it's only meant for constructing some other tests, like for example this one over here. So if I'm going to browse this object, this example over here, it's going to say, give me that cozy corner with abilities and the menu, and then given this order and place order, right? So I'm going to say I'm going to construct the place order message. I'm going to tell Alice guest to place an order at table 1, and then I will write my assertions. Right, so up to here, this is like a test. There's no difference. I set up something, and then I assert that the desired properties are in place. The only difference is between this and a test is that this one returns an object. So this is a return, and I return, in this case, I choose to return place order. So when I execute this, because I can run it as a test, so it's green, but when I execute this, I also get this object, and then all of a sudden I can have a conversation. So my normal TDD flow also leads to, it also provides me the unit of documentation. Because here on the left-hand side, the only thing I've done, I said, here, given this example over here, show me this preview with the propagation of messages. And then I put together a documentation. So this is a live document here. You can go and type in it. Does it make sense? So again, like the difference here between a test, so we made the test support the flow by basically having the continuation here. So first of all, we almost never want to program without an object. We want to program and live, or program as much as possible against a living object first. And the second thing is that, so in order to do this, we want to go as quickly as possible from the dead code to a living object, right? So this is why we wanted to have these tests get us quickly to instances that and then we can play with. So now, once you do something like this, right, then the other interesting thing is how we use other examples. So here I can see that I reused another example over here. Alice guest itself is an example. Table 1 is an example. All of them are just examples. So, and then if I look at the dependencies of these examples, I can see how I can construct different pieces of logic. So an example is also a unit. I can say, somebody can say, oh, remember the example that we played with last time? And then say, yeah, sure. Let's take that one, combine it with something else, another example, and then we're going to construct a third example. And that's it. That's the flow. And notice how everything happens completely integrated. It's the same few operators that we combine over and over again from a UI perspective. We're not introducing a lot of new, we're not talking about 100,000 features. It's just a language that you once you learn, you can compose many, many different kinds of narratives with it. Does it make sense?
Yep.
So, right, for example, this is one of those examples that I like to show. This is a model for prices, which is based on the money model that comes from came a long time ago from the TDD book, right? When you say, you can say, I want 42 euros and I get that, and I have USD and I get this. And if I say 42 euros plus 42 euros, I get 84 euros. And if I say something like 42 euros plus $42, I get $42 and 42 euros. So I get a bag without having to convert those things. And now notice how, again, like I can mix and match a specification of the test if I want to with how it looks like. So now on top of it, we built another model another domain design for prices. So prices, I have this interesting thing, for example, of handling discounts. And the way we handle those kinds of discounts was through something like this. I have here a concrete price of 100 euros, and then I discount it by percentage with 10%, and I get 90 euros. Right. So then, interesting is when we start to combine these things in more complicated types of views or types of prices. I have here a concrete price discounted by 10 euros fixed amount, and then discounted by percentage 10%, and I get 81 euros. So again, like you can reason about this again, about the algorithm, but just looking at how it prints itself. So this is also another example with another case in which we first built the algorithm, but the algorithm, we couldn't draw it. We couldn't draw the bubbles, and the main people drew the bubbles. So we wanted to be able to draw the bubbles. And so first it was just a function that would just accumulate the discounts, right? And then we'll give you a return. And because we couldn't draw in order to draw the bubbles, we needed to kind of pushed us towards this immutability, right? So now we're going to say, oh, let's use a decorator pattern here. And now a decorator pattern naturally records the activities that happen there. And so you can draw them afterwards. So kind of snowballs like this, right? So, okay, so we kind of covered a bit of the space. We started from this idea of how could we rethink why reading is an important problem to address, and then how could we address it. And the way we think we should address it is by constructing this aggressively constructing views for every single problem we have. And literally, every time we're uncomfortable with the problem that we look at, we're going to stop and make it look comfortable. The problem, not the solution. We want to see the problem before we go forward. And very often the other thing is that we talk about how should the demo look like. So the way we plan, for example, things is never by these are the features that we want, but literally what's the story that we're going to tell at the end? right? What's the narrative? And some narratives are about things that the user, that an end user will see. But most narratives about the systems are about something that nobody else will see, but they are still equally interesting. In fact, many of these kinds of things that you're seeing here can be, we're building such views and make them part of pitches, like startups pitching for investors. And instead of using a slideshow, they literally give us the pitch inside a development environment, but just arbitrarily showing objects in the system. This is how high level we can raise anything inside a software system. You can just project it and add the context to it such that you can extract value that nobody's ever extracted. And this is what I was talking about, the second, third, fourth order type of effects that are actually the interesting things. So the way in order for this to work, you have to have an environment that first of all allows you to create these views quickly, different projections, and then compose those projections into narratives. So here, more technically, you're seeing actually a knowledge management system with a multi-language notebook, all in one, inspectors that can be extended in many different ways. But the language of the environment is actually rather simple. Like you don't have many operators, but then they can still be combined in many, many different ways. And then we looked at two kinds of use cases right now. One of them was say, well, let's reverse engineer data. And the other one was, let's see, how do we document a future design or a design in progress? And how do we go about that new thing to build? And they kind of complement each other, and very traditionally people think of them as being distinct activities. And often they address those distinct activities in different tools. For example, for an API tool, it's not unusual for people to have a separately dedicated tool for it. But of course, if you have a dedicated tool for your API, you cannot mix and match it with the other one, with the other activity. And very often, people today don't build systems really from scratch. Even if they build it from scratch, like the code is written from scratch, the data typically isn't. So you kind of want to, during your domain discovery, it's very, very interesting to be able to learn, oh, what about this data? Do we see these kinds of patterns in the data to inform the new kinds of designs? So having the ability to ask these kinds of questions, or simply saying, oh, here's a new model. Let's quickly say, can we import something from the old data and then populate something in the new model just to see how it would look like? Those kinds of things are very, very interesting. And you can only easily do it if they are actually, if you can have them in the same place. And the reason I wanted to show you those perspectives, which again, like they are typically seen differently, is because if we rethink the way, if we rethink how we look at our environment, and the fact that they are in the end, they are actually not different. That has very large repercussions afterwards, because it means that we can reuse things and arbitrarily or at will, we can say, oh, I want actually to look at the system from this perspective, that perspective, this perspective. Sometimes runtime, sometimes statically, sometimes data, sometimes some configurations, or any arbitrary configuration about this. And at the end, that's the essence of reasoning about the system. That we should never limit our ability to reason about the system based on technical boundaries. Because any boundary in software is arbitrary. And what you will see also in the next session, we will look at, for example, how do we reason about architecture? And again, like that's another whole new area that people think that's totally different. It belongs in a completely new kind of tool with new kinds of features. And we think it doesn't. And because of that, you can have all sorts of, because of that, it means that you can invest one time in a set of skills and then reuse them many, many times over. Okay, thank you very much for this first session.
Thank you.
Thank you very much.
And I'm looking forward for the next one.
Yeah, thanks. It's very impressive. I feel like I already installed it while we're talking. I want to play with this.
Excellent.
But yeah,
Great.
it looks very inviting to want to try stuff as well, right? It's very appealing.
Cool.
All right.
Thank you very much. And
Thank you. See you next time. Bye.
See you.
Next time.
Bye.
Bye.
Bye.